The AI-powered Proteomics data report agent that I have built reads a customer SOW and automatically runs the required data analysis. It then generates a clear customer-facing report and can answer questions using both the report as the context and also a RAG corpus as the context source. So, so before I dive into actually giving you the demo of the actual agent and how it runs, I was first would like to start off just giving you a brief overview of the architectural diagram. Basically, the customer uploads SOW, which is in the form of a PDF, which is parsed, and then a LangGraph orchestrator takes over and routes all the decisions and calls several tools, such as tools that would parse and work with the yield data, work with the protein root data, and then also generate some of the plots that are required by this particular SOW, and then finally build out the report. And then once a report is generated, the user can have an interactive session in which they can ask questions um, on the report context, or they can ask questions using the RAG corpus as the context. And also one thing to note is that right now the RAG corpus is technically just any publicly available data such as publications, best practices, and tech notes. But in the future, you can also add to this RAG by adding on several proprietary databases and other, maybe assay development material that right now this demo only uses publicly available data, and the LLM that is powering all of this is OpenAI, and the other tech stack is I've been using LangChain, LangGraph, OpenAI, Weaviate for the RAG, and Streamlit for the UI. Okay, so I also want to give a brief overview of the statement of work that customer might be providing. In this case, all of this is made up data, is aging biosolutions, and they might have several deliverables that they require, covering different teams, maybe assay development and other teams within the company. This agent deals only with the data analysis aspects, and so we are skipping the assay deliverables, and we will focus on the data science deliverables. And in this customer requires 96 well plate yield plot, some bar plots of protein group counts for each sample, and a PCA plot. So these are the things that this tool can generate at the moment. And as input, it would we would require the yield file, which can be in this case uploaded. I mean, basically what the contents of it, which is a each for each sample, there is a yield and an associated well where it was processed. And in addition, there is a file that comes up from the mass spectrometry pipeline itself, which contains the sample and also all of the protein groups that were associated with that particular sample. Again, both of these files are from published data, and they can be uploaded. In this demo, it will be uploaded. There's also you can also use internal SDK to retrieve this data. The demo, I'm using published data and will be uploading. So those, again, let me talk a little bit about the RAG itself. So the RAG, again, is a corpus of all of the published technical notes that that is relevant to this technology. Some of the best practices for again for the tech, and also several any other information that's publicly available at the moment. So with that, think I'm ready. I think I've given you overview of everything that's needed and what's powering all of this. So I will give you run through the demo of the actual agent itself. So I'm uploading the customer SOW. Then I'm uploading my yield data. Then I am uploading my protein counts data. And I'm leaving these as optional. I'm leaving them as is since they're optional. Going to generate the report. And the LangGraph agent has taken over and has created the report. And I am going to. So here's the report itself. And so here again, the customer is aging biosciences, biosolutions, and here the table contains a bit, basically a study summary, the 96 well yield heat map, protein counts, and the PCA plot. The summary is we processed 14 samples. There was a total of 10,000 protein groups across the samples, an average of 9,400. And here is the heat map of the 96 well plate, listing all of the each of the samples and their associated yield. So that was the first requirement. And then the second requirement that was there on the deliverable was some protein group counts for each of the samples. And then finally, the third requirement was to generate a PCA plot. And here's the PCA. And you can see that the send samples are separating away from the pro samples in this case. So that is the PDF as of now. And now that we have this PDF, we can go back to the tool app itself and ask questions um, that would be based on the PDF or alternatively on the RAG corpus. So first we'll ask some questions on the PDF. Let's say um, how many samples were processed. So it says total of 14 samples, which is what we um, we saw. Okay, and let's ask another question. Maybe on a well location. Maybe okay. Let's say one of these wells and how much the yield was. Let's say A10 maybe. A10 is yeah. Well, A10 and what is its yield? Okay, there you go. Um, Sen 3 and 4.52. Now I'm going to switch over to the RAG corpus and ask some questions. Let me see. Let me start with what are the controls for the stack, basically. Here it's this user controls, process controls, digestion cleanup controls. So if I go to the best practices, that's the best practices. And that's the thing that's listed here. Maybe I can now ask alternate questions. Maybe I can ask about what is recommended for normalization. Okay, it says for more studies, PepCal normalization. And so if we go here, and I look for there it is. It gives you a whole bunch of different normalization, but the recommendation is use PEPCAL based normalization for most studies. And so this is how this whole thing works using both, now you can query both your report, and once you have some insights from basically you have some questions based on the report, you can further have a question answer session and get some guidance from the RAG corpus that is relevant to this particular tech.